Hi everyone. On page 10 and 11 in the Year 8 Forces Notes, there's a series of experiments on transducers. And what we're going to do is we're going to go around the class, we're going to do these experiments, and I'd like you to pay attention to what energy changes take place. What energy do we start off with? What energy comes out? Is all the energy useful? And so we'll go through and I will talk through each of the questions that are on those little experiments. And I'd like you to, as you watch the video, take down notes and record what you think your answers are going to be. Let's have a look at the first one. Experiment number 1 has a clockwork toy. Here we've got a little witch. And it says, wind up the toy and let it go. Write down the energy changes that occur. So whenever we wind up a clockwork toy, well, there's energy being stored inside. There's a spring that we're sort of coiling up. So what sort of energy starts off when it's held in a spring that's wound up? Then when we let go, she seems to be limping a bit, but she's moving. You can certainly hear her, and actually there's a bit of energy inside that you won't really be able to detect. These things heat up a little bit, so you need to think about what energies go in. What do we start off with? What energies come out, and what do you want to come out of a clockwork toy? What's the purpose of it? So what's the main output energy? Let's look at number 2. Okay, here we've got a very simple circuit. It has some batteries or cells, 2 of those. This is a switch, and we've got a light bulb. So what happens when we push the switch? Well, you can see what happens there. You can describe that. And write down the energy changes that occur. So what do we have in the battery? What does that turn into in the wires? And what comes out of the bulb? By the way, how does a bulb work? Don't know if you can see. There's a very thin wire inside a bulb. That's the bit that glows. And it actually glows white hot. So was the bulb meant to give out? And how does it produce it? On to question 3. Okay, question number 3 involves stretching an elastic band. It says stretch it between your fingers. Okay, and if we do that, we've basically got a catapult. It's going to fire something. It says fire a small paper ball at a wall, not a person, using the catapult. So if you do this at home, please don't aim at your pets or siblings or parents or anybody else. I'm going to fire this. A bit hard to do with the camera. I'm going to wrap that around. So what sort of energy do I start off with? And when I fire it, what does that turn into? So I want you to write down the energy change that takes place. For question 4, we've got a slightly more complex setup. We have a power supply that is connected to a motor. It's connected by a rubber band to a pulley, which is connected to this bit with a bit of string on it, down to some weights that are swinging down here. So what happens whenever I turn this on? Motor turns, and we can see this starts to wind up the weights, and we can see they're slowly rising up. And I can turn up the power to make it go a bit faster. And I can turn it off. So what energy changes took place? What did I start off with in the power supply? What does the motor turn that into? Now that energy is just transferred by the pulley. And then it causes these weights to move up. So what sort of energy do weights get as they gain height? So we've got something in the power supply, to something in the motor and the pulley, to something gained by the weights. And whenever you're writing down the energy changes, use an arrow. So you can write down what you started off with first, arrow. What comes next, arrow. What comes third? On to question 5 on page 11. This is a loudspeaker. This is a loudspeaker. So inside that there's basically a cone connected to a magnet or these sort of things that can move whenever it's powered up. And it's connected in this case to something called a signal generator. The signal generator is something that just gives out an electrical signal. And so we can see here they've got these wires that are connecting to this electrical output. And if I turn it on, you should hear a noise. I can adjust some of the properties. I can make it quieter, maybe louder, and I can change its pitch. Make it very high indeed. And in fact, this can go up much higher than humans can even hear. However, it's very low. And if I put my hand on that, I can actually feel that moving a little bit. So, what energy changes take place? You're asked for what do we start off with? What comes out of this? What does it make this do? And then finally, what comes out that we can detect? So there's 3 energies that we're interested in there. Number 6, in some ways, is quite similar to the loudspeaker. But instead of having a signal generator just giving out electricity, such, we've got a battery, and we know what's stored in a battery. We've got a switch, and in this case, we have a buzzer. When I push the switch, you can hear the buzzer going. So let's think of the energy changes. What do we start off with here? What comes through the wires? What comes out of the buzzer? And don't forget to use arrows to show a flow of energy from the first thing to the middle to the end. Finally, with number 7, I have a microphone. And the microphone is connected through wires to this thing, which is called a cathode ray oscilloscope, or a CRO for short. And what this does, this detects an electrical input, and it just shows it as it is displaying the screen. So we don't have to worry about the light coming out, that's a different thing. We want to think what energy changes take place in the microphone. And you can see when I speak into the microphone, you can see that something's happening to the display. Don't forget, this display is measuring an electrical input. And it only gets a reading when I put sound into it. So I want you to identify what sound takes place, what energy change takes place when I put sound into the microphone. What goes in, what comes out.